Hello, everyone. I hope you're all feeling happy, safe, and healthy. Thank you for joining me for another daily dose of math. Today, we're going to talk about some new data that will let us know when New York City is getting back to normal. We'll look at a couple puzzles, and as always, we'll end with some positivity. Let's talk about it. A lot of people have been wondering when we are going to be able to get back to normal. There has been a lot of talk of New York City schools staying closed for the remainder of the year, and everybody really wants to know, when can we expect this to end? When can New York reopen? So we're going to take a look at a series of tweets by Mark D. Levine, who is a New York City council member for the 7th District, which services some of Manhattan. He released a series of tweets including some data that we need to watch for. The health department has released this data that we need to watch for to track when we will be able to get back to normal. The first piece of data we need to be watching is hospitalization admissions, which means new people admitted into New York City hospitals. If we can get that number below 200 a day, which is this line on our graph, for 10 consecutive days, that will be the first good sign that we are maybe ready to reopen New York. This graph, if you look back on our horizontal axis, starts at April 2nd with right around 700 new hospitalizations. It went down for a while, and then around April 5th, it started going back up. But since April 6th, it has been steadily going down, new hospital admissions, and this is all a result of the social distancing we've been doing. We want this graph to continue trending downward until we hit this line, and we want to stay below that line of 200 for at least 10 consecutive days, 10 days in a row, where the number of new hospital admissions are below 200, and we are trending in that direction, so that's good news. The next piece of data that will tell us when we are ready to open New York up is the percentages of tests coming back positive. So of all the people who are tested, how many of those tests come back positive for the coronavirus? We need this rate to show 10 consecutive days of decline. So 10 days in a row it needs to decline. There are two pieces of information on our graph. We have testing that's been done at the Public Health Laboratory, which is a specific laboratory that has been servicing the most unhealthy people in New York City. So theirs is a little higher because their health in general has been lower, so more of them have the coronavirus. All of New York City testing is this brown line. We need this rate to decline for 10 straight days. If you notice, the brown line declined from the 5th to the 6th to the 7th to the 8th to the 9th. We had a few days, but then it spiked back up. So we need that to decline for 10 straight days. And we also want it to be below this brown dotted line, which is just under 20%. And for the public health laboratory, we want it to be under this blue line, which is right around 30%. So we need these two lines to be declining every day for 10 days, and that is, again, the percentage of New York City residents who tested positive. The final piece of information that Mark Levine is tweeting about and talking about the health department is the number of coronavirus patients in critical care. This chart is for public hospitals only, and it hasn't been populated with historic data yet, meaning data from the past. So it's not really useful yet because we can't compare it to the norm. But we should keep an eye on it because we want to see this drop for 10 consecutive days also. So the number of people in critical care across New York City health and hospitals, we want this number to drop for 10 consecutive days. It's hovering right around the 800 mark here, but it does look like it's starting to maybe go down. If this number starts to go down for 10 consecutive days, that would be great. So these are the three things we are looking for. We want to see the percentage of tests coming back positive, the number of people admitted to hospitals every day, and the total number of people in critical care. We want all of those things to decline for at least 10 days in a row. If we see that in the data, then we know that social distancing is working, and that sooner rather than later, we will be able to get back to some sense of normalcy. So keep your eyes on those numbers. Let's talk about our puzzle of the day. We had to figure out what all three of these shapes were equal to. For the sake of this problem, I'm going to call this tree X, I'm going to call the cactus Y, and I'm going to call the other tree Z. So first here, this is just to make it easier for me. First, we're going to look at these cactuses, or our Y. I think each of those are equal to 5, because if you add 5 plus 5 plus 5, you get 15. So that gives me these two equations. I can cross this out and write a 5, and here I can write a 5. I am going to rewrite these two equations up here. First, I have x minus 5 plus z equals 11. If I simplify that equation by getting rid of this minus 5, if I add 5 to both sides of this equation, plus 5, plus 5, I'm doing some algebra here, I am left with x plus z equals 16. That's one equation that we have right here, x plus z equals 16. So our two values have to add up to 16. Now if I write my other equation, this one, if I write that one here, let me erase that inaccurate arrow. This arrow doesn't belong there. If I write this equation here, I'm left with something like this. X plus 5 minus z, because remember this tree we're calling z, is equal to 13. I'm going to do a similar thing over here. I'm going to try to get rid of this plus 5. Here I'm going to subtract 5 from both sides because I want to move that 5 over to the other side. So I'm left with x minus z equals 8. Now this step is where many people may have gotten stuck because you see two variables in each equation. You have x plus z equals 16. So these two shapes have to equal 16. And these two shapes also, when you subtract them, have to equal 8. So when you add these numbers up, we get 16. When you subtract them, we get 8. Two methods of going about this. The first method, which is the way that I first thought about this problem and my wife first thought about this problem, was let's think of first all the numbers we can that add up to 16. Well, you have 16 and 0. You have 15 and 1. You have 14 and 2. You have 13 and 3. You have 12 and you have 4. And you could keep going 11 and 5, 10 and 6. But let's just start with these 5. If you plug these into this equation and you subtract 16 minus 0, that equals 16. So that's not it. 15 minus 1, 14, no. 14 minus 12, that's 14 minus 2, I'm sorry, that's 12. No, that's not it. 13 minus 3 is 10. Nope. 12 minus 4 is 8. That's what we're looking for because this equation says that if you subtract them, you get 8 right here. So we know that x has to be 12, meaning this shape is 12, and our other tree is 4, and our cactus we know was 5. So 5, 12, and 4 was the solution. And we used a little bit of algebra, a little bit of guess and check. Now another friend of mine, James, solved this using something called systems of equations, which is the much more precise way to solve this. When you have two equations with two variables in each of them, or three equations with three variables, four equations with four variables, that's called a system of equations, a set of equations, and we can sort of work with them together to solve them. So in order to do that, I'm going to show you real quickly. I'm going to take this equation here, and I'm going to rewrite it. I'm going to add z to both sides so that I get x is equal to 8 plus z. Now, why might I want to do that? The reason I want to do that is because now I know what x is equal without having to write the letter x. So I can take my other equation from earlier, which says that x plus z equals 16, and instead of writing x plus z equals 16, I'm going to write 8 plus z, because that is equal to x, and then I'm going to add z, and that equals 16. The equation that I just wrote is the same thing as x plus z equals 16, which we saw right here. That's the same equation. Instead of writing x, I just wrote 8 plus z, which is what I solved for using the other equation. This is called substitution. You use one equation to solve the other. So if I simplify this equation, it tells me that 8 plus 2z equals 16. I can subtract 8 from both sides, and I find out that 2z equals 8. Divide both sides by 2, and I find out that z is equal to 4. And that is what we found out already. Once I know that z is equal to 4, I can take a look at my other two equations, and it's easy to see that x has to also equal 12. So a lot of thinking going on here. That was a long explanation. If you followed all of it, great. If you followed some of it, great. If you followed a tiny bit of it, great. If you're totally confused, great. Today's puzzle of the day is another mobile puzzle. For those of you who don't remember, this is how these work. It is a perfect balance. So the total weight of the mobile is right here, 48. And when you have a balance, when you see a bar like this, that means that the balance is split in half. So half of that 48 is on this side, and half of that 48 is on this side. You see there are other balances too that split the remaining weight. So you can use this to figure out the value of our 3 shapes. Have fun. I hope you guys enjoyed today's episode. Thank you again for joining me. As always, we're going to end with some positivity. And for today, I just wanted to remind you guys that all of the hard work we're doing by staying inside and not going to school and not seeing our friends and some of our family, all of that is paying off. Because as we saw with the data we looked at the beginning, we are starting to see some good signs. So we finally have some good news. And all of that is a result of the hard work that we've been doing. And thankfully, all the hard work that the people who are emergency workers and work in healthcare and work in stores and anybody who's going to work right now, it's their hard work who's really helping us stay home and us be able to flatten that curve or bring down a lot of those numbers. So that's our positivity for today. Even if this is feeling like exhausting and really stressful, just know it's working. What we're doing is working, and we got to keep it up for a little while longer, but there are positive signs happening. So I hope you all enjoyed today's episode. I hope you, again, are all feeling happy, safe, and healthy, and I will see you soon. Thanks for joining me.